In this video, we will be using Statcrunch in order to perform linear regression. If we select Stat, then Regression, you have a couple of different options, but we're only using simple linear. We select our X variable, the independent variable, which we want to be the test takers. And the Y variable is our dependent variable. And we want to look at the composite score. Now, you can also perform hypothesis testing on your y-intercept and on your slope. You can also create confidence intervals. You can also perform predictions, transformations as well. You can create your graphs. So here we have a fitted line plot. You can also create your residuals, a histogram of your residuals, a normal probability plot. In this software, they call it QQ plot. Your residuals versus your X, your predicted values versus your residuals. And I would like this. So select the first one. You can save your residuals. And with your scatter plot, you can also indicate the labels for your x-axis and your y-axis and the title of your graph. So once we press compute, we are given all the information we need. You can maximize the size of your box. Here it's letting us know we have 2 pages. So on the first page, it lets us know what our dependent variable is. Our independent variable is our X. Our dependent variable is our Y. And here is our best fit line, our least squares regression line. So the best line that fits through these points, they, instead of using X and Y, use the actual label of the column that you used. And it's written not necessarily in our regular slope-intercept form. So test takers is our independent variable. So this is our slope. And it's also indicated in the table at the bottom. Here is our y-intercept. That's also listed in the table at the bottom. It gives us our sample size, lowercase n. It gives us R, our correlation coefficient. And this software, they use capital R. We use lowercase r for our correlation coefficient. So if we're interpreting this, this says our direction. It gives us our direction and our strength and direction of the linear correlation. So it's 0.29, about 0.3, which is close to 0. So there's not a strong relationship between, but it is positive because this number is positive. And here we have R squared, which is our coefficient of determination, which tells us how much this model explains the relationship between our test takers and the composite score. And normally we change this number to a percentage. So 8.9% of the variability in the composite score is explained by this model, which is not very good. We also have our p-values if you're doing hypothesis testing here. And then at the very bottom, hypothesis testing for the particular model. If you need your residuals for each of the counties, the residual is given in a new column right beside the value. We can use the arrow at the bottom to go to the next page. And here is our scatter plot of all of our number of test takers and the particular scores. And it gives us our best fit line. If you highlight over it, you can see the equation, and they do replace the titles of the columns with X and Y for you as well. You can also click on the points and it will tell you what row it matches and the specific information, the x and the y's that correspond to it.